Okay, guys, so let's start over chapter number three. And chapter three is about Linux operating system. We have three main things to discuss in chapter three, starting with the Linux overview. I'll give you the definition of Linux. Then we will discuss some importance or value of Linux. The third item is we will discuss the use of Linux in SOC, Security Operations Center. Then the second agenda item is Linux administration, and specifically we will discuss how we can manage services in Linux, and we will also discuss how to make the system hard the systems. The third agenda item is the Linux host, and specifically we will discuss GUI, graphical user interface. I'll just give you some different description of GUI. In fact, what are the different components of GUI in Linux? And we will discuss malware, whether Linux is prone to malware or not. If it is prone to malware, which particular malwares can be avoided, and how we can get rid of some of the malware. So starting with the definition of Linux. So Linux is basically a collaborative effort. Nobody own Linux. So Linux is basically, like many companies, they participated and then they actually came up with this operating system. So Linux is basically a collaborative effort, not owned by one organization. Number one, Linux is open source. Another definition for Linux is it's basically open source, and source code is free to download and free to modify and modification as well. Like for example, if you know the let's say the programming language on which that Linux operating system has been designed, you can actually customize that particular operating system as well. Number three, initially Linux was designed for network servers. So initially it was designed because Linux is a broadcast operating system. So initially it was designed for network server, but can be used with personal computer, PC, personal computer as well. Most of the Linux flavors are absolutely free, besides some of the flavors like Red Hat Linux, Debian. Some of the Debian flavors, they are not basically free, and you have to pay a little fee for to use those. So most of most of the Linux flavors are free, but some are paid operating system, like Red Hat, one of the examples for that. This is just an overview of Linux, or you can say the definition of operating system for the Linux operating system. What's basically which feature or which these are the four main features which actually make Linux the first choice in a security operations center, SOC. The first is it is open source. Open source mean now you can develop your own security framework, because it gives you liberty to code, to design your own security framework. Like you can add as many security layers as you want. And another best part is Linux distribution offers free support. So free, no cost support as well. For example, if you have any question, if you are having some issues with that operating system, Linux distribution or operating system, so you can directly contact to the developers. For example, if you have issues with the Kali Linux, CyberOps, TinyOS, stuff like that, so you can directly get some support from the developers. Then the CLI is the command line interface, which is the powerful mode of communication with operating system. And most of the Linux, they do offer, beside the GUI, in fact, they do offer CLI as well. Like 100%, of course, all the Linux, they do that. To communicate with the operating system, beside the CLI, they do offer GUI and CLI. So you can control or you can run application or services by using graphical user interface. I'll discuss that GUI in a while. Or you can write down the commands and you can do, or you can run services that you want to. For network applications, the Linux, it is very flexible to design network applications. You can put the client server software, anything, whatever you want to put to manage a network. It's very easily compatible with Linux. Linux in Security Operations Center. The best thing about Linux is Linux can be customized with any of the tool or any of the software that might be used in the Security Operations Center. So Linux is basically kind of more flexible, compatible, or customizable tool, in fact. So Linux can be customized with any of the tools which might be required in SOC. And specifically in SOC, Security Operations Center, what they do to find vulnerabilities of computers and networks. The Linux administrators use pen testing tools. So these pen testing tools can be added to your Linux flavor. Some Linux administrator, or you can say the pen testers, they use Kali Linux, Parrot. There are many tools, operating system like that, because those operating systems come with plenty of tools, pre-built-in tools. Like you don't have to put the tools in order to do pen testing and all. So most of those tools are absolutely free, and it's basically compatible with Linux. Like most of the pen testing tools are basically compatible with Linux. You don't have to put any kind of dependency or dependent software in it. For Linux shell, as I already talked about, you can use CLI or you can use GUI. The CLI, the command line interface, is basically called Terminal Emulator, and you can directly communicate with Linux with your kernel as well by using CLI. There are many commands that we will discuss in our file and directory command section. But one of the command which is very commonly used, it is called man. Man stands for manual. So this particular command, it displays, if you just type man space whatever, if you want to learn, for example, if you want to learn about any of the commands, you just have to type man. It displays the documentation of a specific command. What does it mean? So it means, for example, if you type man space man, so what it should do, it will display the documentation about man command. Okay, so for example, if you type man ls man, for example, mkdir, stuff like that, so it will give you documentation about that particular command, like how that command can be used, which other parameters, argument can be passed, and all that. So man basically stands for manual. For some of the file and directory command, for example, let's say if you are in Windows, let's say if you wanna actually display the current directory means, let's say you are in desktop. For example, on CLI, you are in desktop and you want to see the folders on your desktop or the files on your desktop. In Windows, we just type dir. If you just type dir, it will show you current directory. Like current directory means it will show you the folders or the files in that particular directory. In Linux, we use command to list, to display the current directory. That's called list. So it will show you current directory. It will show you all the folders and all that stuff in that directory. For example, if you want to see the permissions, in that directory, like the files and all that. For example, let's say you want to create a file. Let's say I want to create a text file. So if you type a command touch and the name of the file, let's say xyz.txt. So what will happen, this particular file like xyz touch will create a file xyz in the directory where you currently are. Let's say if you are on desktop and if you type touch xyz.txt, so it will create a text file on your desktop. Now by default, if you want to check the permissions of xyz.txt, for example, you are logged in as admin, so of course you will have read, write and execute request. So basically in Linux there are three type of user. The first user is called admin, which might be you, administrator. Second is called group, where you can assign permissions to a specific group, and third is called public. By default, whenever you want to check the set of permission, let's say I want to check permissions on this particular file. So the command is ls-l xyz.txt. It's basically list the permissions for that particular command or that particular file. So by default, if you have created this file with the admin username and password or admin account, so you will see rwx w minus or hyphen, and let's say r hyphen. So what does it mean? It means the first three symbols are basically for admin, and this is for the three are group, and the last three are basically for your public. Okay, you can always change, you can always manipulate with that. So r mean read, write is for w, x is for execute. So it means admin can read, write or execute this file. Group can only read and write, they cannot execute, for example. You can always change it, of course. Public can only read that file. Now, for example, if you want to change the permissions, so read number is, there is a code. Read is basically, it has 4 number, write is 2, execute is 1. So if you add them all together, that's 7. So let's say if you want to give admin full rights, so admin should have 7. If you want to give full authority to your group, so 7. For public, let's say you just want them to execute, number will be 1. Okay, so like it should be 1 if you want it. If you want to, if you let the public, like if you let the public read the document as well, so it's gonna be 5, like 4 plus 5 so they can do that. So how you can change the permission? So if you want to change the permission of the file, just type chmod and then the code number. Let's say 775 and then the file name. So what will happen if you run this command? The command, you can say the permissions have been changed. Now you are basically giving read, write and execute to admin. This 7 is for the group, read, write and execute, and 5 mean you are basically letting the public read and execute only. Okay, like for example 5. So you can always change it. Let's say if you put here chmod 111. So what will happen? Admin can execute only, group can also execute, and public can also execute. They don't have read and write access. So these are some of the things that I believe everybody should know that, and you will experience that in your lab. The next is the Linux the Linux administration. In the Linux, we use a specific kind of file which are called configuration file. So the files that are used, or which are used mainly to manage services are called configuration files. So these configuration files are basically text file. For example, let's say if you have any software installed in your computer, that particular software will have a configuration file, and these configuration files are text-based documents, including firewall, antivirus system, anything, whatever in the Linux, it must have a configuration file where Linux administrator, they can manipulate with the commands with the file. So configuration file or text-based file, and where the administrator, admin, can define services, port numbers. You can block port, you can enable ports, the client authorization details, etc. So this is basic, and you can always manipulate if you know the Linux programming. So that's basically in the Linux programming, the configuration file could be written in Perl language. It could be in, let's say, Python. It could be in Python as well. So you can manipulate with the configuration file if you want to disable services and all that. And that's the way how Linux administrator they do. If you want to make your devices harder, so of course there are a few suggestions. One is enforce periodic password changes. Like you need to make your group people or your employees maybe to make the password changes like 180 days or 90 days or stuff like that. Enforce strong password requirements. You need to monitor logs, block unused services. Okay. What else? The last agenda item, the Linux host. And to control a Linux host, we have a CLI. We already talked about CLI, command line interface. We can type configuration files in command line interface. And some files or some applications can be managed using GUI as well. And what is a GUI? Graphical user interface. It provides a visualization of your hard drive. Like you can visualize where the data is stored. You can manage the data more easily. GUI is more convenient as compared to CLI. It's more easy, more convenient. Okay. Four things in GUI in a typical Linux you will see. One is the top bar menu. It shows right onto the top. So top bar menu, what is that? It's basically, it shows you currently running applications. So you can see the currently running applications on the top bar menu. Other than that, you can see there's a launcher as well, which is basically app launcher, application launcher. Then there is a quick list. What is a quick list? Quick list is basically, it's a short list of tasks that applications can perform. So application can perform, that's basically the quick list. Then another option is called system and notification. And that particular thing, what it does, you can switch between the users. You can shut down a computer. You can, for example, restart. You can put the computer on sleep, etc., etc. So these are different features that are found on GUI. Installation of application in Linux, it's not that easy as compared to Microsoft Windows or you can say Macintosh. But again, how Linux has made these installation and removing of the software more easy. In Linux, we use the packages, like installation packages. So Linux and all the flavor of Linux, they support different kind of packages to install a program or to remove a program. These packages are package managers. Typically, the name is package managers. You can use those package managers to update all the applications all together, to upgrade all the application all together, rather than manually updating one application at a time. For example, one of the application manager that we use in Debian, it's called apt. It's the package manager which is more commonly used in Debian. Yum is another package manager which we use typically with Red Hat Linux. These are the two main package managers. apt is we use apt for Kali Linux as well, for CyberOps as well, in order to update the file, upgrade a file. So for example, if you want to update all the software, you just have to type here apt-get space update. If you just type this particular command, what's going to happen, it will update all the applications. For example, if you want to upgrade application, so the command is apt. That's basically the package manager. Apd upgrade. So apd upgrade manager, it will actually upgrade all the files. And for example, you can fire these two commands all together by putting and you can type both of these commands all together as well. If you want to specifically update a program, so we type here sudo and then apt get update and the name of that software, for example Python and whatever the software is. So that's basically the way how we can update a file, or you can upgrade a file as well. We already talked about process in the last class. Process is basically it's a running an instance of computer program. A program, when you run a program, multiple processes execute all together. Sometimes one process is running at a time. So running an instance of a program is basically called a process. I think we already talked about it in our, I don't want to spend more time on that. You can watch the previous video if you want to learn more about process. Malware in Linux, some people, they believe Linux are absolutely, they are free of the viruses. That's not the case. Although they're less prone, but it doesn't mean that there is no virus, no malware for the Linux. We still have the problems of worms. We still have the problems of Trojans in the Linux. Rootkits. The biggest problem in Linux is the rootkits and viruses, of course. These are the typical viruses still possible in Linux. The biggest problem is rootkits, because if you have a rootkit in your operating system, specifically in Linux, it is impossible to get rid of it. And in Linux, if you want to check whether I have a rootkit or not, so just type a command chk rootkits. So if you run this command in root directory, it will actually check if there is a rootkit or not. And how they can detect that? Because they will check all the kernel files. And when they find any file which is unnecessary present there, so they will let you know. Like kernel has all the files which are required to boot a computer. So when you just type this command check rootkits, it will go through all the kernel files required to boot a computer. And if they find any file which is extra, not required, so then they will let you know, hey, it could be a rootkit. And if there is a rootkit present in your kernel, it is impossible to get rid of it. Okay. So that's it about chapter number 3. If anybody has any question, just reach me out. I will upload a new video for chapter number 4. Thank you.